Okay, let's review some of the derivative taking from chapter 3 here as a review for test 2. So the first one here, find the derivative using the limit definition. Okay, so if we're going to do the derivative of 5 over x using the limit definition, then let's remember that that means f prime of x is the limit as h approaches 0, f of x plus h minus f of x over h. That's the limit definition. And then, so if we apply that to this function, we would get the limit as h approaches 0. F of x plus h would be 5 over x plus h minus f of x is 5 over x all over h. So that's the way we've set it up. Now I notice that if I were to plug in h of 0, I would get 0 over 0. So this is one of these limits where we have to get out of that situation. And the way I'm going to do that here is I'm going to get some common denominators in the numerator there. So I'm obviously from this numerator here, I'm going to need a least common denominator of x times x plus h. So the 5 over x plus h is going to need an x over x minus the 5 over x is going to need an x plus h over x plus h all over h. And cleaning that up on top, I would have 5x, so this whole numerator is going to be over x times x plus h. So 5x minus 5x, and then distributing minus 5h. And this is all over h. So if we clean that up a little more, all right, the 5x minus 5x is going to go away, minus 5h over, and now x times x plus h, and then this h in the denominator. So if I take the numerator, instead of dividing by h, multiply by 1 over h, then that's just going to put h in the denominator. All right, so we see the good news here is that those h's are going to cancel. And I'm going to get negative 5 over x times x plus h. And now I have a situation where I can simply plug h of 0 in. And I would get negative 5 over x times x plus 0, so x squared. And there we go. There is our derivative. Note that if I wanted to check this by the rules that we know, if we have f of x is 5 over x, I could rewrite that as 5x to the minus 1, and then indeed the derivative would be negative 5x to the minus 2, which is the same. Okay, so let's move on. Let's do some derivatives by the standard rules of differentiation, so not by the limit definition anymore. Okay, find the derivative. Y equals cube root of x plus sine of x squared. X squared, yes. All right, the first thing is I'm going to rewrite this because I don't like using the root notation. So this is x to the 1/3 plus sine of x squared. So no derivatives yet. That was simply rewriting that first part. Okay, so then y prime. So I have two things added, so I can just take the derivative of x to the 1/3. That's 1/3 x to the 1/3 minus 1, so minus 2/3 plus. All right, so now I have sine of x squared. Right, that's sine of something. So its derivative is cosine of that something times chain rule says go inside and take the derivative of what was inside, and so I get a 2x. So I have 1/3 x to the minus 2/3 plus 2x times cosine of x squared, just reordering things. All right. How about f of x is ln of secant squared x? Now I could look at this as just an ln and say derivative ln is 1 over that thing times the derivative of that thing that's inside. But if I'm looking for this sort of thing, realize that this is ln of secant x squared. That's just shorthand inside. So using some simplification, 2 ln secant x. Okay, so I simplified that just using those logarithm rules, and now I can go ahead and take the derivative because I have a constant multiple 2, and then I have ln of secant x. So that would be 1 over secant x times the derivative secant x, which is secant x tan x. And what I see is that the secant x's cancel, and I get 2 tan x. All right. 2x cubed over x squared plus 5. All right, first thing is to identify the situation. This is a quotient rule. So with our quotient rule, we know it's the derivative of the top, so 6x squared, times the bottom as it is, x squared plus 5, minus the top as it is, 2x cubed, times the derivative of the bottom, which would be 2x, all over the bottom squared. And so now I just have to clean this up a bit. So I'm going to get 6x to the 4th plus 30x squared minus 4x to the 4th over x plus 2, x squared plus 5 squared. And what do we get here? I get 2x to the 4th plus 30x squared over x squared plus 5 squared. And if I factor out a 2x squared, x squared plus 15 over x squared plus 5 squared. Okay. All right, y equals 2x minus 3 times 5x minus 6 cubed. My only alternatives here are to multiply that whole thing out, or better idea is use product rule. So if I want to use the product rule, I have the derivative of the first, which is 2, times the second as it is, plus the first as it is, 2x minus 3, then the derivative of the second here. So the derivative of 5x minus 6 cubed, right, that's something cubed, so that's a 3, 5x minus 6 squared, times, go inside, take the derivative of what's inside, 5. The rest is all going to be cleaning this up. All right, 2, 5x minus 6 cubed plus, we have a 15, 2x minus 3, 5x minus 6 squared. Now take a look. We actually, for factoring purposes, we have a 5x minus 6 squared in both of these terms. when I pull that out, I'm left with a 2 times 5x minus 6 plus 15 times 2x minus 3. So clean that up a little more. 10x minus 12 plus 30x minus 45. And now 5x minus 6 squared times 40x minus 57. There you go. Okay, this is a nasty looking one here. Okay, so the first thing I want to do is rewrite this. X cubed e to the sine x to the 1/2. And then note that, all right, this is all something to the 1/2. So the derivative is 1/2, that's something inside, to the minus 1/2, times, now I got to go to do the derivative of the inside here, the x cubed e to the sine x, which is a product rule. So derivative first, 3x squared e to the sine x as it is, plus, first as it is, e cubed, x cubed, derivative of e to the sine x, that's e to the sine x times cosine x. Cosine x is the derivative of the sine x on the chain rule. All right, so there really isn't a lot more for me to do here, but how you might see this written is something like well, we could put the 2 square root of x cubed e to the sine x on the bottom. In that part in brackets there, we could take out an x squared e to the sine x, and then we'd be left with 3 plus x cosine x. So that's how you might see it written.